Systems of equations can be solved in three different ways. One of the ways is using graphing. And we need to make sure we understand how to do that, especially when they give you a graph and they ask you to solve it using the graph. So what we're going to do is plot both of these equations on one grid at the same time and see where they intersect, if at all, and then determine what our answer is going to be. So to start off with my first one, I've got an m of negative 5, 3, and a b of 1. So if you're struggling with graphing lines, check out one of the earlier videos on how to graph lines. So I'm going to start my b value at 1, which is where we begin, and I'm going to move down 1, 2, 3, 4, 5, and across 1, 2, 3, and I'm going to put my next point. If I were to go up, it would be going off of the grid just a little bit, but I could show you an estimate. It would be 1, 2, 3, 4, 5, 1, 2, 3. It would be about over here, okay? And so what I'm going to do is make sure I connect my points. So I'm going to make sure that you're using a straight edge, okay? I'm going to put an arrow at the end, and I'm going to label it as y equals negative 5/3, x plus 1. Okay, let's do the second one. I've got an m of negative 1/3 and a b of negative 3. So I'm going to start at negative 3. And what I'm going to do is you can rise. So since it's a negative slope, I'm going to start going down and then over 3. And then I can just go in the other direction, up and to the left 3. Again, the other points are going to go off of the grid. So just put as many as you possibly can. And I'm going to connect these, okay? I'm going to put an arrow at the end, and I'm going to label y equals negative 1/3 x minus 3. And so we do need to state what the solution is, so circle the point that's overlapping, and your coordinates for this would be 3 and negative 4. So that is your solution to this system of equations. Let's take a look at another example. My m for this first one is going to be 4/1 because it's not written as a fraction. And my b is 3. So I'm going to start at 3 and go, I can't go up 4 because there's not enough spaces. So I'm going to go down 4 and to the left 1 because I want to have a positive slope. Down 4 to the left 1. So I could fit a couple of points on there. I'm going to connect them. Okay, and then make sure that you're using a straight edge. Make it as best as you can. Y equals 4x plus 3. My second, the slope is going to be a negative 1/1, and the b is going to be a negative 2. So we want to make sure that we're having a negative slope. So it's really important that you remember the difference between what a positive and a negative slope looks like. That way you can determine when you're finished if you're correct or not. And the other thing that I always recommend that you do, especially if you have extra time, is plug these into the calculator and make sure that what you see when you graph it is exactly what your picture looks like, okay? They're intersecting here at negative 1, negative 1. That is our solution. Okay. Let's take a look at another example. There's 2 more down here, and these look a little bit different because they're not written in the proper format, okay? So what you want to do is get y by itself for both of them. So I'm going to start with the first one, and let's see what that's going to look like. Subtract 5x to the other side, and I've got y equals negative 5x plus 4. Okay, and so my m is at negative 5, and then my b is that 4. So I'm going to start at 4. I can't go up, so I'm going to go down 5, and then over 1. And I can't go another down 5, so I'm just going to plot the ones that I can. I'm going to redo that line. It's a little bit easier for you when you have the straight edge to follow. Okay, looking better. Label your line with the original equation. And now let's take a look at the second one. It says x minus y equals 2. I'm going to move x to the other side. I've got a negative y equals a negative x plus 2. Now I have to get rid of that -1 that's in front of the y because I don't want it to be negative. So y is equal to negative over negative is going to give you a positive x, and then this is going to give you a -2. So I'm going to start at a -2, and then I've got a positive slope. So rise 1, run 1, and continue as many points as you can on your grid. You see where they're intersecting. Okay. And circle your point of intersection, which is going to be a 1 and a -1. That's your final answer. Okay, taking a look at our last example, and then we're going to talk about a special circumstance. So I've got x plus y is equal to 3, minus x, y equals -x plus 3. So I'm going to start at my 3, and I'm going to go down 1 to the right 1 to make sure that I have that negative slope that I am looking for. I want to continue, so I'm going to go up 1 to the left 1 so that I can make my line as long as possible. Okay, make sure you're putting arrows at the end, labeling with that original equation, x plus y equals 3. And I'm going to check out my last one, 8x plus y equals -4. Move 8x to the other side. Y is equal to -8x minus 4. So I'm going to start here. And -8 is going to really be -8 over 1. So I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8 to the left 1. And I can really only fit those 2 points on my grid. Okay, so I'm going to connect them. And I am going to put arrows. And you can see that they're intersecting at that point, which is a -1 and a +4. Okay. If you graph your lines and you notice that they look something like this, that is because the lines are what we call parallel. They have the same slope, you would notice, once you rewrote them in the correct form. And the answer to this would be no solution, because there are no points at which your lines intersect. There's also a possibility that when you rewrite the equations, they end up being the exact same thing. So if you have 2 lines that end up being the exact same, that means they have the same slope and they have the same y-intercept. Therefore, they're the same exact line, and so we call that infinite solutions, because that just means that every single point on that line is a possible answer. And since lines go on forever, my response would be infinite solutions. So make sure you keep that in mind for some special circumstance examples. And I hope you have a better understanding of how to graph systems of equations.